So here we have a ketone that's being reacted with the nucleophile and water. Notice that the ketone becomes an alcohol over here and the nucleophile is attached down here. So we got to draw the mechanism for this reaction. So trying to figure out what the first step is going to be. Notice that the nucleophile has a minus charge and the carbonyl down here is going to act as an electrophile. So the nucleophile is going to come down here and attack the bottom side of this carbonyl. We're going to push that double bond up. We're going to have an O with the minus charge. We're still going to have our two methyl R groups. We're now going to have a nucleophile attached to the bottom here. And for the second step, we're going to take water here and then just use our oxygen to deprotonate that water, giving us the final product. So this is a two-step process. The first step is a nucleophilic attack, and the second step is going to be a proton transfer. So that was under basic conditions. What if we have acidic conditions? Here we have an acid and the nucleophile. So this time first, we're going to protonate the oxygen. So the oxygen is going to come in and is hungry for that proton and deprotonates that acid. We're going to be left with a double bond O, H with a positive charge. The groups are still the same, but then our nucleophile is going to come in and attack the bottom of this carbonyl, thereby pushing that double bond up, giving us the product. So in this case, under acidic condition, we get the same exact product, but the steps are reversed. Step 1 is the proton transfer, and then for step 2, we have nucleophilic attack. So two ways of getting the same product. Here's an example. Let's see if we can draw the mechanism for this following reaction. Notice that we have ETMGBr. This is going to be a Grignard reagent and water. So for our first step, we're going to have our Grignard reagent is basically just going to become ethyl, a charged ethyl group. And this is going to act as our nucleophile. It's going to come in and attack the bottom side of this carbonyl, pushing that double bond up. We're now going to have a minus charge, and our ethyl is now attached as an R group. And then for our second step, we're going to protonate this oxygen. So this oxygen is going to deprotonate the water and give us our final product. Now it's your turn. See if you can draw the mechanism for this reaction. If you're on Instagram, comment the first and second step. If you're on TikTok, take a picture of your mechanism and drop it in the comments.